In this video, we want to continue to look at the standard normal probability distribution, finding area under the curve for any probability distribution, and using our inverse normal. What's going to be different here is, though, we want to do this by using our calculator. So to help us understand this, let's look at two problems here to start off by not using our calculator, just to refresh our memory. So we're going to start off with the probability that z is between 1.1 and 2.1. So from what we've done before, we find that we go to our chart, where if I look at my chart, we go to the standard normal. If I look up 2.2 gives me 0.9861. If I look up 1.1, that gives me 0.8643. If I now use my calculator to subtract those, I get 0.1218. If I looked at z is greater than 1.48, we can do this one, and we would have 1.48. I want greater than 1.48. So as we've done this, remember there's two ways to do this. You could subtract it from 1, or you could look up the negative. I am going to look up the negative 1.48, and I get 0.0694. So that was what was on the quiz. So now let's look at how we can do those by using our calculator. So if we go to our calculator, we're going to use the distribution. And if you remember, we were here before. If we went to the bottom, we had our binomial and our Poisson and our geometric. Now we're going to be at the top. Now, because we have a continuous probability distribution, we are not going to use normal PDF. We're going to use normal CDF. So if we look at our original problem, we want 1.1 to 2.2. So our lower is 1.1, our upper is 2.2, and for right now, our mean, we're standard normal, we're with a z, right? These variables are really important. When you're with a z, that is standard normal, which tells me my mu is 0, my sigma, my standard deviation is 1. I hit enter. Now, for those of you that don't have the previous screen, and it goes right to normal CDF on your screen, your 1.1 is your lower, your 2.2 is your upper, you have your mean, you have your standard deviation, and if we hit enter, we get 1.2176, which you can see 1.218 is what we got from the chart. We're now actually even more accurate on the calculator. We get 1.71762740 and so forth. Now, if we look at this, where we have greater than 1.48, as we go to the calculator to do greater than 1.48, we have a problem. Because this gives us a lower and an upper. So what we have to do here, our lower is 1.48. That's fine. But our problem is our upper. Now, to find the upper, or to put in an upper value, we're just going to put in a really big number. And my really big number is, I'm just going to put a whole bunch of 9s. How many? I don't know. How many? It doesn't care. I don't want to just put in 99, because if we're looking at a problem where everything's in the, hundred thousands or 10,000s or thousands or 90, you want to just put it in a whole bunch of 9s, much more than every other number in the problem. 1.8, this is much bigger. We're still standard normal, so we go down and we hit enter, and we get 0.0694, which you can see that was to 4 decimal places from our chart. Now on our calculator, we obviously have a lot more. So if you have 2 numbers, it's pretty easy. Lower, upper. If you have 1 number, you need to do, 99999 if it's bigger, or if you were going less than, you would want negative 99999 for the lower. If we have, find the z that is 70% is between the 2. So from what we've done, this is the middle 70%. So that tells us that the 2 ends are 0.15. This is like what we did on the... And so we want to find the 2 z's that give us 0.15. So now on our calculator, we are going to be using inverse normal. Now, depending on how old your calculator is, what happens next may be different. If you have mine, you will notice mine gives you the area and asks left, center, or right. So if I'm doing 0.7 to the center, and I hit paste, I get 1.036. I get 1.036 positive and negative here. Now, if I look at my chart, I am looking for 0.15. As we did this on the chart, you will notice the closest I can get on my chart, which would be 1492 is what I find in my chart. That's the closest I can get to 0.15, and my z there would be 1.04. So you see, we're able to get a little bit more exact because we don't have to just pick the closest, we can find the exact value. Now, if you do not have this on the calculator, and it just gives you area, then that means it's going to be by default, always, just like the chart, always going to be left. So I would have to go to the left, which is 0.15. If I hit paste, and there I get the same answer. So if you have left, right, center, you can use that. If you don't have left, right, center on your calculator, it's always going to be area to the left, mean, standard deviation. If we have something like given the standard normal, now we have a new mean and standard deviation, right? So the way we're going to write this is normal CDF are lower, right? If we want to draw a picture here to help us, here is 23 and it's less than, so it's going to go here. So my lower is going to be negative 9999, 23, 24, 2.1. So now if we go to the calculator, always CDF, lower is 0.999999. Upper was 23. My sigma is 24. And what was my 2.1? So notice, if we're doing this on the calculator, we do not, I repeat, we do not have to use the z-score. We do not have to try to convert it to look at the chart. We can just type that in, and that gives us our answer, which is 0.317. If it is between 2 numbers, 21 to 25, we can then just put between 2 numbers. It's 21 to 25. We get 0.606. We can still round this off to 3 or 4 decimal places when we do that. See, that would be 5. So we still want to go, let's go 4 decimal places when we do this. Even though we're on the calculator, we're doing that. So if we have a mean and standard deviation, what's the probability that X is less than 5 years old? That would be normal CDF. Less than 5 would be negative 9999999. 5, this was 8. What was our standard deviation? 1.3. And we get 0.0105. We also can do inverse normal. What would be the top 10%? So we're going to go inverse normal. We want the top 10%. I am going to go right. This was 8. What was my standard deviation? 1.3. And we get our top 10% is 0.9666. Now, when you do this, understand if you don't have that on your calculator, right? You don't have the left, right, center thing. Your calculator is going to be set on the left automatically. So if you want the 10% to the right, you're going to need 90% to the left, and you get the same answer. So you just need to be careful with the left, right, center. We also, just to refresh your memory, we have maybe a problem here where it's geometric. Find the probability 3 times to pass. That's geometric. So remember, geometric, you have your probability, how long it takes to pass, to find your probability. And then also, we'll put some binomial. We will come back and be using binomial again. So just to refresh your memory, where you have your n, your p, and your r or your x when you're doing binomial. All right, you are now able to do the homework, which is really no new problems. We're just understanding how to do these problems by using the calculator.